Hello, everyone. Let's chat about local development and debugging with Tilt. Plan is I just want to show how we can develop and debug with Tilt locally in Cluster API. If you have any questions, feel free to ask at any point in time. If you don't want to interrupt me, just raise your hands and I hopefully will see it. So I'll start with sharing my screen. Hopefully you see my IntelliJ in Chrome. Can anyone confirm?
Yes, we can.
Okay, perfect. Good. Then, so first of all, if you want to follow those sessions, we have a discussion here on our GitHub repository. Let's chat about with previous sessions or future sessions. If you have any ideas for future sessions, any feedback, just respond here. That would be great. But now to the actual topic. Tilt. I'll start with some context. So we're using Tilt for local development debugging. What does that mean? So with Tilt, we're setting up a local management cluster based on our current code on whatever branches we currently checked out. Then we can change the code, redeploy, debug, etc., etc. So high-level features. We can actually deploy our current code and we don't have to wait for any releases or something. We can easily deploy different infrastructure providers. Usually, most of them should be compatible, but we'll see later what that means. Then we can debug into running controllers. So if you have to debug some bugs, etc., we can just add a breakpoint. And what has become more and more useful lately, we can take a look at what metrics and what logs our controllers are emitting to figure out if they are already good enough or if you want to improve them. So we have one page in our book which describes hopefully most of it, which is called Rapid Iterative Development with Tilt. So let's start with prerequisites. So what do we need? Of course, we need Docker somehow to create a kind cluster, which is then the basis for a management cluster. So we also need kind. Then we're using Tilt, of course. Then customize and env-subst. That is mostly used because when we create a management cluster, we are basically simulating cluster cuddle init, and that, or let's say, we're simulating the combination of a release and cluster cuddle init. So when we make a new release, we run all our YAML files through customize, and then we have those manifests that we actually release. So that's the first part. And then cluster cuddle init later on downloads all those files and runs env-subst on them. So we need both those binaries for development workflow, and we have make targets for them. What could happen is that you have some outdated versions over time. Then you have to run make clean bin and build them again. We currently don't have any kind of detection if those binaries have the right version. They are also stored in some, let's say, a cluster API specific path. So we have hack tools bin, and so we're not using any env-subst or customize that you have somewhere in your path. Then if you want to deploy, we called it observability. So something like Prometheus, Loki, Grafana, Promtail. Then you also need Helm because we consume those as Helm charts. And last steps, clone cluster API and every provider that you want to use with Tilt. So now let's actually use it. So first of all, you have to create a kind cluster. I'll try to make that a little bit bigger. You could just use kind create cluster, but if you want to use capd, you either have to create a kind cluster with volume mounts manually, or you can use that helper script. So that script actually just deploys a local kind cluster, but with the right configuration. So let's take a quick look. As I said, if there are any questions, just ask. So what that shell script does, I don't go into the details, but essentially it deploys a kind cluster with those volume mounts and with a registry configured. Not sure. Oh, okay. The network thing seems to be for the registry. So first we create a kind cluster with that configuration. Those volume mounts are for capd, as I mentioned. Then we're doing some network magic, and then we're deploying a registry on top. So once that script is done, we have a local kind cluster with a registry running on top that Tilt will use to store and pull images from. Yep. So that's where I already am. I already did it before because it takes like, I don't know, 1, 2, 3 minutes or so. And I didn't want to wait. Then minimal tilt. So we have a tilt configuration file where you can enable all kinds of features that we've documented here. But I would say a minimal tilt settings looks roughly like this. You have to configure which providers should be used. And usually you use the kubeadm bootstrap and control plane provider. You don't have to enable the core provider. So the cluster API controller deployment is always enabled. And in this case, I'm using Docker, but obviously up to you. It should be possible to deploy any other provider as long as they have, let's say, a relatively standard cluster API layout with things like, as far as I know, at least that's a requirement. So with those customized files, etc. And they require a tilt provider.json. That should be documented somewhere. Yeah, I'll just show you one. So I think the most popular providers like AWS or Azure, they should just have those. But if they don't, what you have to do is add a config file like this. And that config file specifies the name of the provider. Then I think that's just the image name, which is used by Tilt. It probably has to match the image name that you have in your YAML files or something. Then Tilt can automatically redeploy. That's the configuration for which files should be watched for that redeployment, or which files and packages. Then we have labeled, we see that later in Tilt. That's for the UI and the manager name. So yeah, not sure for what exactly those individual fields are used, like manager name here, but should be relatively straightforward to fill out. Yeah, and once we have that stuff, we can just use Tilt up. Let's see what Tilt up does. So first of all, it goes through our Tilt file. Yeah, oh, Vinny or Shreya was first, I think. I hope I pronounced the name correctly.
Yeah, can you hear me?
Yeah.
Yeah, so yeah, I had a question from the Tilt file that we were looking. If we change the name of the manager, will it create a manager with the name that we change?
You mean
like
here,
in the
previous?
Yes, in the previous slide, in the Tilt file, where we are giving image name and the AWS manager name in the provider file. So if we change the name, will it change the actual container name as well? Or it's just a placeholder?
I think it is used to match something. Let's see. Or maybe it's not even used anymore. Fabrizio, do you know by any chance if you're there?
Because I think most likely the image thing, at least in the other provider that I was looking, doesn't matter even if you change it.
Yeah. I'm not sure. I would have expected. So we're reading that JSON file somewhere here. And I would have expected that we actually use that field. Okay. But I'm pretty sure we don't, which would mean, yeah, that's probably legacy.
It's not an important question. Thank you.
Yeah, no problem. Fabrizio, do you have an idea?
It should be probably used because we are building we are replacing the entry point when we do the bug, for instance.
Yep, but that's not the name of the manager container image. So I think that's roughly the deployment name or something.
No, it is the executable name. It should be, if I'm not wrong.
Yeah, I actually worked on adding that. So if you look at the PR I posted in chat, it's actually it adds the name when you see the Tilt file.
Yeah.
Actually go to the conversation section.
Yeah. So I think I'm definitely sure that we need a label. I'm just super confused if we actually use the manager name somewhere, because I would have assumed that my grep here works, but it doesn't.
Oh, yeah. So Stefan, if you go to conversation and go all the way down, I actually captured the screen image.
Here in conversation.
Go down after the change. So the Kappa controller, go a little bit up, Kappa controller, that's added. Before it was
okay, so it changes.
Unlabeled.
Yeah, okay, that's what a label is for. But I'm wondering if the mention name makes a difference or not.
We can check it. Let's take an action item.
Yeah, I'll make a note just to test it locally. I mean, we already found 2 unused properties last week, so could be that it's used, or we'll find out. But otherwise, I mean, the only way that we actually use it is that we use some kind of string concatenation on the manager name key, because otherwise I would have really assumed that I find it in a tilt file. But let's see. Vinny, you also raised hands before. Was it for the same topic, or do you have another question?
Yeah. Oh, yeah. I actually have a different question. So can I run multiple providers in tilt? The reason I'm asking is I actually run capg and kappa at the same time, but it's not working for me. So I'm not sure if I'm doing something wrong or it's not supported.
It should work. I was frequently running capd and kappa in the same cluster, and that worked. But it would be interesting to see if there are actually some incompatibilities between those 2 providers, or if, But I would say, in general, it should work. We're not aware of any dependencies that should make it impossible, but maybe there is one that we should fix even.
Okay. I actually do it again, and I actually saw an error that I cannot find the default provider, but I can check it again, and if it happens, I'll raise an issue.
Yeah, absolutely. Please let us know. Okay, perfect. Good. Let me check where I was. Roughly at tilt up, and if there are no other questions, then I'll continue. Okay, but feel free to ask at any time. Okay, so I ran tilt up. And the first thing that tilt up does, or one of the first things, is it's running tilt prepare. I think I go over that very quickly, and if you have some time at the end, then we can go into it further. But essentially, we have our own binary, which Fabrizio wrote, and when the tilt file here is run, it first generates a lot of resources, and then it's triggering, or maybe before, probably before. I guess somewhere at the beginning, it's running tilt prepare, passes in a bunch of parameters, and tilt prepare is rendering YAML files. So when you look into tilt build YAML, then we see all kinds of things that have been generated by tilt prepare. Tilt prepare is also doing more things. It's also deploying cert manager, for example. Did I miss anything, Fabrizio? I don't know. We're generating YAML files and deploying cert manager. I'm not sure if it's more provider provider resources.
Maybe a little bit of context. So the problem was that, okay, when we start tilt, basically it's like starting cluster API. That means that it's like doing kubectl init and deploying, and basically the copy release. So you have to start from the config file, apply, customize, and subs, and so on and so forth. And then you have to apply to the cluster, and then you have to install a cert manager, wait for it, stuff like that. Before, all these steps were executed, basically, were implemented in the tilt file. So the tilt file was complex and long. And they were executed in sequentially. That means that for starting your tilt environment, it took something like 4 or 5 minutes. Now, with this tilt prepare stuff, we're executing 2 sets of tasks in parallel, and this basically gives you everything is needed to start the tilt environment in around 20 seconds, something like that. And so, yeah, the experience is just better. And yeah, we have everything in our code. Eventually we can write tests and stuff like that.
Yeah, exactly. So mainly because it's way faster and better to program than I think Starlark should be what tilt file is using. So I think eventually our goal is that we only keep in tilt file what is either easier to do there or what has to be done there. So there are things like resource definitions for, I don't know, Docker build or something that has to stay here. But I think otherwise we try to move everything that makes sense into the binary. So there's one PR open, for example, too. Oh, I shouldn't go too deep. So we're doing some customization to our entry points and commands, and that's currently partially done in a tilt file and partially in main.go and in tilt repair. And now we're trying to move it entirely to tilt repair just to make it easier and testable and all that stuff. Okay, so yeah. So when I run tilt up, first we run tilt prepare, which, as mentioned, generates a lot of YAML files and also deploys cert manager. And then tilt calculate all those resources. And that's, for example, where labels come in. So when we look here, we have different, so that's just, I guess, a category or a label or a group defined by labels, something like that. So we can see all binaries in that tab, which are just the builds of an individual binary. So that thing here is just building the main.go of capd, for example. Then we have the corresponding controllers, which are the corresponding deployments. So when we look here, what we actually see is that we are building a Docker image, or rather two. I think it's a multi-stage build, if I remember correctly. So yeah, definitely. And once that build is done, the image is pushed into our local registry, and then we're deploying the corresponding deployment, which is essentially the same, which is done by classical init. So we try to make this as similar as possible to classical init. There might be small differences, and let us know if you have some problems. But should be like, I guess, 95% the same, and it works great for us. Once the deployment is actually deployed, tilt is waiting for your pod to get ready, and then it's tailing the logs. So now we're seeing that. If you want to redeploy, I'm still not sure which buttons I have to click, but let's say I want to rebuild a binary. Probably I only have to click one of them, but I want to verify that. So if you rebuild a binary and then redeploy it here, then redeploy the image. In theory, you should live reload the image. I'm just not super sure it actually works at the moment.
No, it works. Probably you have set manual reload in your tilt setting.
Yeah, but if I have manual reload, do I only have to click at that button and then even, or? No,
because so tilt has this nice feature, which is basically a live reload. So you can change your code, and then your code and then you can redeploy without restarting your environment, which is super cool when you develop. And so in order to make tilt live reload, basically, we are not using the same Docker file that is used when we deploy copy. We are using a slightly different one that basically split the build process in two. The first one is we build the binary locally. And if you look at the folders in the tilt build, there is bin. So we build the binary locally, and then we embed the binary in the local images. This is much faster than basically having tilt mounting your local source file. So we have this two-stage build in tilt. And so whenever you change your code, if your tilt file is configured for automatic reload, everything happens. Tilt knows the dependencies, and so it rebuilds the binary, and then it deploys the controllers. If you go for manual update, which is something that I usually do because I don't want that every time I save a file, everything gets redeployed. Usually I change 2-3 files. When I'm sure about my change, I decide now it is time to redeploy. So if you want to control, you have to click these two buttons.
Okay, so yeah, I got the automatic redeploy feature if it's enabled. I was just assuming that even if it's disabled, I only have to click one of those buttons. But okay, apparently not. Good. By the way, I just had 2 manager binaries here. That was just because one was very old. But I'm still wondering why we only have 1 manager binary here. I hope all that stuff is run sequentially. But I'll check. I never had problems with the wrong binaries and the wrong images, so that shouldn't be an issue. That it's just one. Yeah. Okay, good. So yeah, we talked about binaries, controllers. That's the same, just grouped by provider, and that's where the label is used to group them by, I don't know, CapD, Kappa, whatever. By the way, for the providers which are in the core repository, we essentially hard-coded that information. So we have basically also a provider JSON, but it's just already embedded in our tilt file. So it's not like we need different information. It's just like we already have it here. Yeah, and then we have observability. I'll show the config later on, but essentially we can currently deploy, let's say, logging and metrics, but I'll show the configuration later. And yeah, so that's that page. There's also that one, which shows a few more things. So that other thing was resource view, as far as I know. That's the overview. So what you can do here too is for some of our deployments, we have a port forward configured. So for example, for Grafana, I have localhost 3001 here. I can just click on it. And then out of the box with the configuration I will show in a minute, you already get a deployed Loki stack, for example. You can roughly get the same today on Cluster API main. Just the logs are slightly different. They're not that good yet, but hopefully will be soon. But yeah, so if you're on Loki and want to see logs of a specific controller, you can just filter by app. Yeah. I didn't deploy a cluster yet, so we'll see that later, how to filter on clusters and things like that. You can also switch data source to Prometheus. So, and then you can just browse metrics. I don't know, controller runtime. There should be something like reconcile. Yeah, reconcile total or errors and stuff. So I think if you're working on metrics, then you can use that too. Hopefully we will improve the whole observability story that we have some built-in dashboards here in the future, etc. But we're not there yet. Okay, yeah,
sorry. No. The idea is that we want to make logs, metrics part of the developer workflow. So we can basically test, look at them like people do in production. And this is why we are making this tool part of our development environment.
Yeah,
and not after.
Essentially, we want to bring production to upstream developers so that we are taking a little bit better care of our logs and our metrics. So it becomes also easier to debug in production. That's roughly the idea. Okay, so next up, I would show a little bit what you can configure in tilt settings. So as I mentioned before, the full reference is here. So feel free to just go over it. But I just do a quick overview. What is possible. So first thing, allowed context. That's just a security mechanism where you can say that tilt should only deploy to a specific kubeconfig context. You don't really need it for kind because somewhere in the tilt code, it's already enabling deployments to kind because it knows that it's just a local cluster. But if you are deploying to some other Kubernetes cluster and if you want to make sure that you're not deploying to production, which happened to me once or twice at another company, then you should set allowed context to be safe. Because it happens very quickly that you just play with kubectl, your context switches, you run another tilt up, and yeah, you deploy interesting stuff on customer clusters or something. Next up, you already mentioned that trigger mode. So yeah, you can I'm not sure what the default is, but you can set it to something like automatic. You have to Google what the exact enum is, but you can also set it to manual. I'm personally also using manual because I'm using autosave in IntelliJ, which is kind of the default as far as I know. So it would deploy all the time. If I click on another window, the files would be saved and it starts deploying. And I just want to have more control. But of course, both works. Then registry. I'm not using it, but in theory, you could configure to which registry or with which registry Tilt is working. So you could also push to, I don't know, Docker Hub, GCR. Probably doesn't make a lot of sense because locally it's just faster. But in theory, you can do it. Then provider repositories. That is important if you use providers which are not part of the core repository, so that we can actually find them. So the usual pattern is to just check out providers at the same level, and then you can just reference them like that. But of course, you can place them wherever you want. You just have to figure out the path. So I usually keep those just always configured for providers I'm actually using. And then when I want to enable or disable provider, I'm just using that tag because that decides what is actually deployed. So in my case, I'm just using Docker and kubeadm, but you can also deploy AWS or other things. Talking about AWS, some providers require additional configuration, which is documented for some of them here. So AWS, for example, requires credentials. So if you want to inject credentials into the AWS controller deployment, you have to set that customized substitution here. As far as I know, if you don't want to put credentials into that file, you can also export an environment variable. That should also work instead before you run Tilt up. But yeah, that's just a more convenient and insecure way to just put your credentials here. Then when we are at customized substitutions, that roughly is just, yeah, what you can usually do with env-subs. So when you look at our quick start page and all the variables that you can set when you deploy with Cluster Kernel init, it should be, yeah, it should be that section. So if you want to customize something, some of that stuff, you could put them all there. What I'm using is I'm usually enabling just all feature gates we have because I usually like to use them. So you can also enable feature gates like that. They are documented here, the names of those feature gates. But yeah, as far as I know, we currently have those three plus ignition. But oh yeah, probably providers have more, as far as I know. Then deploy cert manager, so you can enable or disable if Tilt up will deploy a cert manager or not. Only actually makes sense if you want to deploy your own cert manager, which is probably not really required for the dev environment. Then we have some extra arguments. So if you want to, yeah, essentially roughly append arguments to your managers, we currently have PR open to improve that a bit so that there's some small gap there, but let's assume for now that you just can do that with all flags. So if you want to enable another logging format, for example, or change verbosity, et cetera, just set the extra args. That string here should match to the provider name here. So it will, yeah, just correlate to each other. Then we have deploy observability. Those are our currently possible values. So you can deploy Grafana, Loki, Prometheus, Promtail. So Grafana is just the UI. Loki is essentially the data store for logging. Prometheus is the data store for metrics. And Promtail will automatically tail the logs of all pods and send them to Loki. That's roughly what they are. But we have them also documented here. Yeah, and then we have some debug configuration. Yeah. So as before, those are matching to specific providers. Then that is the debug port. Yeah. So if you want to debug, you usually compile something with debug symbols. Then you connect with Delve against the port opened by the binary. Well, that was not good. So let me show you. That's probably easier to understand or to summarize. So when you enable the port here, and when we now take a look at a manager port. So first of all, we compile that manager automatically with debug symbols. So you will see in that view somewhere up there that we use the corresponding, or I'm not sure if you actually see it, but when we compile the binary, which is maybe here, yeah, here, then we debug it with debug symbols. And when we calculated the deployment, then we made sure that the manager is started with Delph, which is the debugger, and essentially Delph runs a debug server inside our pod, which listens on port 30,000. And the only thing that we have to do is connect against that port. So that's what that is enabling. And usually in your IDE on client side, you have another Delph running, and that Delph is connecting against the server Delph. Yeah, we have continue. Continue means if you use continue true, then the binary starts immediately. If you use continue false, then your binary starts and waits for the debugger to be connected. So I'm usually using continue true because, yeah, just more convenient if the controller doesn't wait for you to connect. So I'm running all the controllers I have usually with the debug configuration because it's just, yeah, it doesn't really matter for me. And I can connect to any of those controllers at any point in time if I want to. So I don't have to redeploy anything. I just run them all the time like that.
Stefan, just giving
yeah.
Step back. So with Tilt, let me say, out of the box, what you get is that you can run your container and you can see logs. Okay, and usually your development workflow is that, okay, you write some code, you apply some YAML, and you look at logs if everything works. Okay, then you go, you try to fix it, you redeploy, and stuff like that. So it is already a great improvement before the previous way of working, but doing this way, basically, you don't have all the nice debug watch stuff that an IDE can give you. So by enabling the flag that Stefan is showing, what we can get not only that Tilt runs the environment, but when something is happening, we can place a breakpoint and jump into the code and understanding exactly what's going on. And I think that now Stefan is going to show this.
Exactly. Okay, so yeah, controller is running. What I'm doing is I connect against one of our controllers. I'll just take the cluster controller in the cluster API controller binary. What I need is a remote debugging configuration. We also have the configuration for VS Code in our documentation if someone uses VS Code. But it's essentially very easy. We only have to create a Go remote debug configuration. Host is just localhost. That's the port of our configuration. So in my case, I have some predefined ones. That's so I bind the main controller on 30,000, and then I have other ones for KCP, etc. Yeah. So what I'm doing now is I connect against that, and you also see some kind of error message here, which is kind of fine. Not sure why that is, but it's okay. Not a problem. I just set a random breakpoint here at the start of our reconcile. I'm currently not hitting the breakpoint because I don't have any clusters in Tilt. So up until now, we have a full management cluster, but we don't have any clusters deployed. So what I usually do is I have a whole, I have essentially examples for everything that I want to play around with over time, YAML files. So in that case, I just take, let me copy that. I just generate a new cluster, but usually for the things I try to play around with, for cluster class, etc., I just have some YAML files lying around that I can use and play around with. So that command will generate just a regular cluster YAML. So that's also without cluster class, etc., just to keep it simple. So just a regular cluster template, cluster, and all these other resources. And then I'm deploying them as usual, just like in a quick start. And here I am. So now if I want to, I can just go through all that stuff and figure out what that controller is actually doing, etc. So from here on, it's just plain Go debugging, which probably not everyone is using a lot, but it's not super complicated, and with some exercise, it's kind of fun, at least for me. Yeah, so that's how you can debug. And yeah, if you want to take a look in KCP, you can just start another debug configuration, and now you can also take a look at. Oh, but I have to look up where that file is, or what the name of the controller is. Oh my God. We really have to clean it up. Yeah, so that's KCP. So I think for me, there are two reasons why I actually do that. One is fixing bugs, and the other one is trying to figure out how something works, because we have some fairly complicated controllers, in my opinion. Okay. So let's drop that bracket here. Yeah, so that's the kube reconciler. What you can also do, which is kind of interesting, you can also jump into webhooks. So let's just make an example. If you want to figure out how that webhook works, here KCP. Let's just go over here. So here we have that validated update function. We can just add a breakpoint somewhere here. And I just added KCP and change something. That should fail because an even number is not allowed. Yeah, and now we can go through that validation and figure out what is going on here. So I think in that case, it should be something like cannot be an even number. Exactly. And if you're really interested in how conversion works, you can do the same for conversion functions. So just a very quick example. If you want to see how the conversion works from beta 1 to alpha 4, and I'm not going into details, I have a separate video for that. Yeah, you can just do kubectl get on Kubernetes control plane, and you say v1 alpha 4 here. And so because we're using beta 1 to store the resource, that triggers a conversion from beta 1 to alpha 4. So if I run, okay, something is wrong. Probably that was the wrong function. So we have that convert to and that convert from function. Yeah, so now I'm here and I can take a closer look how that actually works. Yeah, I'll probably leave it at that with conversion, otherwise it takes a bit longer. Okay, so far, any questions? Make sense or crazy stuff? I don't know. I got used to it. But,
yeah, it is pretty powerful. You are debugging a live cluster, basically. We did something similar also in production, but yeah, it is kind of Tilt is nice because it gives the environment properly set up. Doing this in production is not so easy.
Kind of bad, actually.
Yes.
Okay, so one additional thing I want to show. What I did up until now was I used Tilt to deploy a management cluster on all those controllers. Then I did something manually, and then I debugged those controllers or the webhooks. What you can also do is, if you want to, or if you have to, debug your end-to-end tests, you can run an end-to-end test against that Tilt cluster. So usually an end-to-end test creates a new management cluster and just uses that. But you can also use your existing Tilt cluster, and then you can essentially step through your end-to-end tests and your controllers at the same time. So you can figure out what is happening during your end-to-end tests. And I don't know, if something is not going as planned, you can just pause your end-to-end test, debug through your controllers, play around with kubectl, etc., and just yeah, take all the time you need, because usually I think, yeah, I mean, end-to-end test is kind of a black box. You run it with make or so, and then it works or not, and maybe it times out for 15 minutes and then it fails, but it's not very easily locally debuggable, in my opinion. And Fabrizio, please interrupt me if I forgot half the context, which is useful.
No, I think that the main point is that I don't know many. Yeah. At the beginning of Kubernetes or control development, it was really hard. It was the developer experience was just, oh, let's add a log line, recompile everything, retest, and then iterate. And it took longer. Now we can do a lot of fun stuff. We can debug live and stuff like that. That's not mean that you have to do this always, but if you need it, it is a chance. It's pretty simple to do it. Tilt is really great, and we can do this for normal Tilt cluster, so local development environment, or for end-to-end. So yeah, it is a really nice tool to have and to understand how it works.
Exactly. Yeah, but it's very important to keep in mind that debugging is not always the best solution, and you can spend hours going into, I don't know, going through all kinds of libraries that we are using, and it won't really help. So for me, it's constantly thinking about if debugging is actually the right way, or how deep you want to debug and all that stuff, or if maybe just a log line somewhere is actually better. But just one comment about log lines. So when you are connected with debugger, and I can only show it to you in IntelliJ because I don't know if VS Code has that feature. I mean, you can add breakpoints in the sense of that the debugger will actually break here, and you can step through the code, but you can also add things like non-breaking breakpoints. So you can say here that the execution should not be suspended, and then you can, let me go one line below. So no, that's actually okay. Sorry. So what you can do here in that line is, for example, instead you can also just say, hey, please log the cluster name or something. And this will add a dynamic log statement essentially. So whenever that breakpoint is hit, it doesn't stop, but it logs that line. And you can do that in not only in our own code, but also in third-party libraries somewhere down in controller runtime, etc. And that would be relatively hard to do manually. But that's, yeah, I barely need stuff like that, but it can be useful sometimes. Okay, so going back to debugging end-to-end tests. So we also have documentation for that part. So I'm always not sure. Yeah, that's the right document. So somewhere around end-to-end test execution. Here, running end-to-end tests locally. We also have some documentation how you can run your end-to-end test locally with a debugger. And let me search for that file. And what that actually looks like is the following. So I have also, again, run or debug configuration. This time on the Go test. I'll just give a quick overview, but it's all documented here. So we have test end-to-end as working directory. We have an artifacts folder, is where the resulting artifacts of the end-to-end test will be stored. We have a pattern that it actually, yeah, that's just a test function that the binary with which the binary is actually started, but yeah, all document not really important. Then we have an end-to-end config file. In our case, Docker YAML, that should be your, yeah, depending on the provider, another one. Then Ginkgo focus is kind of important that you don't run all the tests locally. So I would only really recommend running one test or so in that style. So I'm just filtering on PR blocking, which in core Cappy case is just a quick start end-to-end test. And I'm using verbosity true, which as far as I know enables also the streaming feature. So Ginkgo usually just per default, or in CI at least, it runs all the tests and then prints out the log output of each individual test at the end of the test, so that you get blocks of tests. And that will enable streaming, which essentially means that every log line is printed out immediately, which in my case just means if I run that configuration, I don't have to wait for the logs until the end of the test. I will see it as far as the log line is actually executed. Yeah, so that's the configuration. Then, oh, I missed something, sorry. So that is the regular configuration if you just want to run the tests against a new cluster. But in core Cappy, we have an additional config flag, which is used, which is called end-to-end use existing cluster. That probably doesn't exist in providers, but should be pretty easy to add if you want to. Or yeah, just ping me somewhere, then we can make it happen. And that flag will will tell the end-to-end test that it shouldn't create a new cluster. It should just essentially use the current context. And if the cluster already exists, then that one is used. Ah, perfect. Happy you also has it. Nice to hear. Just okay, so let's see, existing. Oh, and there's a to-do for me. So actually, you won't really see it in the log lines. That something is different. It will be just faster. Oh, 1 second. Somehow wants a password from me. Yeah, okay, but it works. Yeah, so the end-to-end test, it reads the end-to-end config file. It creates a local repository, which is yeah, all those manifests of the provider deployments. And then what it tells us, and I just made a to-do for that, my local list, it just says it's setting up the Bootstrap cluster, initializing the Bootstrap cluster. Probably somewhere there we should have a log line, something like, hey, reusing existing Bootstrap cluster, if that's doable, but I'll take a closer look. Yeah, then it accesses the already existing Bootstrap cluster, and it tails all the logs. And then we're getting to the actual test case, which is here. And now I can just step through it, and at the same time also step through the controllers and see what they're doing if I want to. So let's just, yeah, that is still active. That's okay. So if you're confused about that icon, that only means that with the currently selected debugger, that code is not in the binary that I'm debugging. So currently I have that end-to-end test here open, which means that it's connected against my local end-to-end test. So I see those red buttons here. But of course, that debugger is not connected against the controller. So if I switch to that controller here, then I see, oh, it's active. And just FYI. Okay, so we're here. Let's see. I think essentially we're deploying the cluster here somewhere. And for just a very simple example. So let's say for some reason the cluster creation fails, and usually the test, oops, okay, that other controller hit. Nice. That other debugger hit. So usually I would apply that file, and then it would wait for the cluster to exist, and potentially it would time out. But one technique is a little bit much, but one thing which is very useful in end-to-end is you can just set your breakpoint before. So essentially, oh, and I really have to continue here. So I shouldn't block the controllers when the end-to-end test is deploying something, because then the webhooks don't work. Yeah, so I essentially just wait here. It's before any kind of wait is started. So now I have all the time that I want, and can can also just simulate other situations if I want to. So I can access that cluster. I should have the quick start namespace here. I know I have the cluster here, and if for some reason I want to play with the cluster, I can just edit it in the meantime, etc. So that's the one from the end-to-end test. Yeah. So I think that's roughly everything. I mean, it makes a little bit more sense in more complicated tests. So for example, our cluster kernel upgrade test or so, where it actually takes, I don't know, 30, 50 minutes to run through the test. It can be very helpful to just pause it somewhere in the middle, and then, yeah, just continue with kubectl and debugger to figure out what your issue is if you have some broken tests or so. Otherwise, it's just rerunning the tests over and over again locally. So that's for me the big improvement, that I can just take the logs of a failed test somewhere, then I can start it locally, set a breakpoint somewhere before the problem happens, and then just continue and find the issue. Yeah, and usually I only have to run the test once or twice compared to trial and error, essentially. Okay, I think that's roughly everything I had. Any other questions, comments? Yeah, Artie, I can imagine it's so time consuming to try and error those tests.
Yeah, and everything is documented in the book. So please take a look. And if the documentation is not good enough, feel free to help us to improve it.
Yeah, or at least tell us. Okay, good. Yeah, Artie.
I don't think this is really related to this particular session, but like if you look in the E2E logs, I always see those S's continuously come up. Like, what is its significance? I actually tried to find it in the logs of the test as well. I went down a rabbit hole, but I never found it. So like while we are at it, if in case you know.
I have no idea.
We have a theory. We have a theory that it is Ginkgo reporting the skipping test, the skipped test, but it is only a theory. We never went verifying what is really is.
Maybe we should.
Okay, because it really like it troubled me this one time because I was just not able to find it. And I think you're right, Fabrizio, because I think I saw this in the conformance tests as well. So it's probably not anything to do with CAPI specifically. But okay, at least there is some.
Oh, I think
it is not. It is not from CAPI. It is from Ginkgo, but I don't know what really means.
Yeah, you're
Okay.
right. You're actually right. Yeah.
Oh, yeah.
Skipped spec. By the way, that was only grabbed here in the Ginkgo.
Okay, awesome. Thank you.
Okay. Any other related or unrelated questions? Okay, perfect. Done. Yeah, have fun. Please let us know if there are any issues or if you want to have some other features there.
Thanks. Appreciate it.
Yeah, no problem. Bye-bye.
Thank you.
Thank you.